Hey guys, today we're talking about solving a linear programming problem. Now, simply put, a linear programming problem looks to minimize or maximize some sort of linear combination of variables by looking at the vertices of a feasible region. Now, there are some steps when we go about solving a linear programming problem. First of all, our first step is to identify our variables. So once we get those variables into place, then we know what our independent and dependent variables might be. We want to write a system of inequalities or constraints. Now this is what's going to limit our problem here. So then we're going to graph those inequalities. So we practiced graphing a system of inequalities in the last section. Then we're going to find the feasible region. We're going to find the vertices of the feasible region. Now the vertices of the feasible region are simply where that feasible region, so right down here, here's our feasible region. The vertices are where the sides of that feasible region come together. So all of these vertices are actually going to represent possible solutions. Then we're going to write a formula or an equation that needs to be minimized or maximized. And then finally, we're going to apply this linear programming theorem, which simply says put in your vertices, these x, y coordinates, into that equation for number 4 and find out which one minimizes or maximizes it. So that's our final step then, is to interpret the results. So let's do a few examples to see how this works. In example 1, we see that Lisa makes necklaces and bracelets, and in her spare time she sells them online. Each week she has 10,000 grams of metal and 20 hours, or 1,200 minutes, to work on producing the jewelry. If it takes her 500 grams of metal to make a necklace and 50 grams to make each bracelet, each necklace takes her 30 minutes to make and each bracelet takes her 15. So this is the perfect type of problem for linear programming. Let's start off by identifying our variables. N is going to equal our number of necklaces. All right, and B will equal our number of bracelets. Now, next, we're going to come up with a system, or linear system of inequalities that function as our constraints. So the first constraint we have is the amount of metal. She has 10,000 grams of metal to work with, and each necklace will take up 500 grams. So 500N plus 50B, because it takes her 50 grams of metal to make one bracelet, has to be less than or equal to 10,000. So there's one constraint. Now the next constraint is her time. It takes her 30 minutes to make a necklace and 15 minutes to make a bracelet, and together they have to be less than or equal to 1,200 minutes. Okay, now the last two constraints are really just kind of understood. B, the number of bracelets, has to be greater than or equal to 0. You can't make negative bracelets. And the last one is that N has to be also greater than or equal to 0, because likewise you can't make negative necklaces. All right, now let's label our axes here. And in this particular problem, we're going to let N equal our X axis and B be our Y axis. So we're going to go up in increments of 10 here. So now that we have our axes labeled here, let's take a second to graph these lines. The first line here I will graph in yellow. We have 500N plus 50B is less than or equal to 10,000. So remember how to do this. We're going to cover up N and solve for B in order to find that y-intercept. So taking 10,000 and dividing by 50 is going to give us 200. So that's going to be way up here off the top of our page. But let's go and find our x-axis by covering up B and dividing by 500. Well, 10,000 divided by 500 is going to result in 20. So it's going to intersect right here. So this is going to be a very steep line that comes down and hits our x-axis right here. Okay, our next one, same thing. We're going to take and cover up our N here and solve for B. 1200 divided by 15 is going to give us a y-intercept here of 80. And then likewise our x-intercept, or our n-intercept in this case, take 1200 divided by 30, you're going to end up with 40. All right, so here is that line there. And finally, n greater than or equal to 0 and b is greater than or equal to 0 indicates that I want everything to the right of the x-axis, or to the right of the y-axis and above the x-axis. So here is my shaded in feasible region. All right. So next thing is we want to grab the vertices from this. So let's grab the vertices. Here is at our y-intercept, which is 0 over and 80 up. Our x-intercept here is at 20 over and 0 up. We also have the origin 0, 0. And then finally we have this little intersection point here. We'll highlight it in blue. And that's going to be the intersection of 10 over and 60 up. Okay. So each one of these vertices represents a possible solution that will minimize or maximize our equation. Now that's the last thing we really need to do, is we need to take a look at this equation we want to maximize. Lisa makes $8 per necklace, so that's 8n, plus she makes $5 per bracelet, so 5b. That's going to equal her profit. Now we want to maximize her profit. So keep in mind here, all these vertices are possible situations. Well, we can take 0, 0 out of the scenario right away, because making nothing is going to produce nothing in terms of a profit. The next one we need to consider is 20 is 0. So if we put 20 in for our n and 0 in for b, that's 8 times 20, and that's going to result in a profit of 160. All right. The next we need to consider is 1060. So that's 8 times 10 plus 5 times 60. That's 80 and 300. So that's 380. And so we got that one and we got that one. The last one to consider is 0 and 8. So that's 0 necklaces and 5 times 80. So 5 times 80 is actually going to produce a profit of 400. So this combination right here, 0, 80, gives us our maximum profit of $400. So she should really produce 0 necklaces and 80 bracelets.